Welcome to Study Loop.
So for part A, let's find the maximum height. We know that Vy final squared equals Vy initial squared plus 2 times G delta Y. In this case, our Y initial is going to be 0. So we can say that here Y max would be equal to Vy final squared minus Vy initial squared divided by 2 times G, and this is equaling negative V initial squared sine squared of theta initial divided by negative 2G. And so this would equal V initial squared sine squared of theta initial divided by 2G, where the negative signs cancel out, and we can solve. So this would be 46.6 meters per second quantity squared times sine squared of 42.2 degrees, all divided by 2 times 9.80 meters per second squared. This is giving us 50.0 meters. For part B, they want the total time in the air, so we can say Y final equals Y initial plus Vy initial t plus 1/2 gt squared. Again here, downwards is positive, so we can say that t is simply going to be equal to 2 times V initial sine of theta initial divided by g. Let's solve. 2 times 46.6 meters per second multiplied by sine of 42.2 degrees, my apologies, divided by G. So 9.80 meters per second squared. T is found to be 6.39 seconds, and of course 0 seconds. However, this answer does not apply, of course. And so we can say that C is found to, we want to find the total horizontal distance covered. So delta x, displacement in the x direction, would equal Vx times t, and this would equal 46.6 meters per second cosine of the angle 42.2 degrees, and then divided by 9.80 meters per second squared. And this is giving us 6.39 seconds. So this would be, oh, my apologies. This would be 46.6 cosine of 42, and not divided by G, but rather times 6.39 seconds, the time that we just found here. My apologies. Delta x would then equal, of course, 221 meters. And finally, for D, we want to find the essentially the final velocity. We know that the velocity of the projectile 1.5 seconds after firing is going to just simply be the vector sum of the horizontal velocity and the vertical velocity. So V for the horizontal, Vx initial, which equals Vx final, because there isn't any acceleration in the x direction. This would simply be 46.6 meters per second cosine of 42.2 degrees. This is giving us 34.5 meters per second. And then we can say that Vy final equals Vy initial plus gt. We can say that this is going to equal 46.6 sine of 42.2 degrees minus 9.80 meters per second squared, multiplied by here, it'll be 1.5 seconds. And this is equaling 16.6 meters per second. So let's draw it, let's write it in vector notation. We can say that the final velocity at 1.5 seconds would be equal to 34.5 I plus 16.6 j hat, and then the units, of course, would be meters per second. Let's find the magnitude of the final velocity after 1.5 seconds. This would be 34.5 squared plus 16.6 squared, all to the 1/2 power. This is giving us 38.3 meters per second. And to find the angle, we simply take arctan of the y component divided by the x component. And this is giving us 25.7 degrees. We have a positive y and a positive x. So this would be in the first quadrant, essentially. So 25.7 degrees above positive x-axis. So this would be the direction and the magnitude of the velocity, again, after 1.5 seconds. That is the end of the solution. Thank you for watching.